Okay, so we've we've looked at our translations up and down in reality, which is just that constant there we add to the right, isn't it? Okay, so I like the way it's translated. If we add a constant to the function, so in other words, we add +1 or -1 or +2, we're shifting up and down, aren't we? And it's exactly the same with our other graphs. We're moving parallel to the y-axis, all right? Or in the positive y direction, however we want to term it. If we add the constant to the x value, which is a good way of thinking about it, isn't it? So the constant's being added in here to the x, either subtracted or added. That's when we're shifting left and right. So obviously if it's a minus pi on 4, we go to the right pi on 4. If we add pi on 4, we're going to the left pi on 4. Okay? And again, we refer to that as parallel to the x-axis or left and right. So bringing all the translations together for our trig function, amplitude, A at the front, N is our period. So think about A. A, whoop, A is a dilation from x-axis, isn't it? Because we're stretching up, we're making the graph go higher. Okay. The N, that's our dilation from the Y. And in fact, it's by 1 on N, isn't it, from Y? So think about if we make, think about sine 2x, N is equal to 2, which means the period is equal to pi. So instead of the graph being like that, okay, we're making it like that, aren't we? So we're squashing it together. Yeah, so we're contracting in, so it's multiplying by a factor of a half from the y-axis, all right? And then B units to the right, C units up and down, all right? So they're the same dilations that we've used for all of other graphs. I guess we've just got to think a little bit carefully about the N value. That's the one where sometimes we may not formally know how to comment on the dilation. All right, so let's all bring that together. What do I need to do here? We have to sketch the graph file, state the period and amplitude. So we've got all things here. So we want to, amplitude is equal to 5. Period is equal to 2 pi on 1, which is equal to 2 pi. We're pi on 4 to the left, and we're 3 units up. All right, so let's go to our axes. Which graph it was? Cos. Just check. We have a domain, 0 to 2 pi. Amplitude of 5, period of 2. So I'm going to cheat a smidgen, and let's just get that bigger. Oh, that's not a very good graph, is it? Amplitude of 5. How do I do an amplitude of 5 on that? Well, we might have to, what's the best way to change the scale, boys? If we make that 1, 2, 3, if we make that a 4, hey? So I wonder if I can really, I wonder if I can really cheat. No. All right. So let's make that 4 and that -4. All right, so the amplitude was 5. I'm going to go back. I can't remember if it's just. So let's bring the graph across. So it's 5 cos x plus pi on 4 plus 3, I think. So that's going to get ugly for us. It's not a very good axis. All right, so first things first, let's just sketch our basic graph. Cosine, amplitude of 5, we go up to 5, down to -5. The period is 2 pi. So there's 0, 2 pi over there. And what are we going to do? So half the period is to there. So the graph will go down through pi on 2, which is halfway, up through 3 pi on 2, something like that. Okay, let's just, okay, so we're going to shift the graph to the left. So we've done the 5, we're going to move it up 3 and to the left pi on 4 units. So I guess because really is a terrible axis. We wouldn't just make do with what we've got, lads. All right, so pi on 4, well, if that's pi on 2, what, 3 sections, pi on 4 is 1.5 sections, isn't it? So 1.5 sections is to there. Let's just mark 1.5 sections everywhere. So the center piece roughly to there, center to there, center to there. So if I bring everything back to there, this piece goes to there. So we've got round to there. So then that's 3 pi on 2. So we're going to go up through there. That's not right. Do the curve on that. To there. Okay. And now the whole thing has got to shift up 3 units. So I reckon the left, right, up and down. Maybe we could have did the left, right, up and down in one hit. So that's at -5. So it's got to come to -2, which we'll call there. Now the whole thing's up 3 units. So let's just do that average value, sort of my y-axis. It's not an asymptote, but it just gives me a nice clear point. I've got to move that up to there, that up to there, move that point up to there. Now these points are up here somewhere. So this is where my scale isn't great. I've got my center. So let's just sketch our graph through. We're coming down to there, up through. There's our graph. Don't forget we've got to sketch it to 2 pi. So it's going to come back down again. And we're only going to sketch it from that section onwards. Let's get rid of that dot there. So whenever we label our trig functions, or any graph really, we should always label our endpoints. So if I put x equal to 0, I get 5 cos 0 plus pi on 4 plus 3. Cos of pi on 4 is 1 on root 2. So that's just 5 on root 2 plus 3. Happy to leave it in that form. So that point there is at 0, 5 on root 2 plus 3. This point here is just 2 pi later. So it's going to be the same value. So that's at 2 pi. And that's the same as 5 root 2 on 2 plus 3 if we rationalise. All right. So we've marked our endpoints. Period. The question asks for the period, which is 2 pi. The amplitude, which was equal to 5. What about a range? What's the range in this case? So we were at, I guess with any trig function, we know we go from -5, because that value there could be -1. So we're as low as -5, but then we came up 3 units. And we're as high as 5, but then we went up 3 units. So we got from -2 to 8 for the range. All right. So this one here, because we're not going to get nice exact values, we would not be able to find our intercepts tech-free. We'd have to use a calculator for that. All right. So these next 2 exercises, F and G, lots of graph sketching. Whether you use the general solution or your circle to solve for your intercepts, that's up to you. But pick one method and stick to it. Keep in mind you will have to work with the general solution at some stage. All right. Yeah, practice lots of these questions, boys.